Hey guys, welcome to another tutorial of vRealize Operations Manager. This is Apurva and today I am going to tell you about alerts in vROps. We all know what an alert is in the simplest of terms. An alert is a way to be watchful of any unusual and potentially dangerous or difficult circumstance in our environment. In vROps, we use it to notice any such possible dangerous event and notify the person related to the event through email or some other way beforehand or in time for successful and smooth run of our environment, and maybe suggest the person to make necessary changes so that we can correct the problem and avoid that unwanted situation to affect our environment badly. Now, for example, say we have a number of VMs running on a host which is part of a cluster, utilizing its resources like CPU, memory, storage. Now, there's no denying that in our environment we want to utilize our resources most efficiently and effectively, but we also need to make sure that no VM is facing contention or has to wait for resources so that it can run smoothly throughout. And as our needs and requirements grow, we are required to add more VMs in our environment. The person who is adding the VM on the host is unaware of the workload that the host might already be facing. Also, in a situation where the person has no other choice than to place the VM on that host only, what must we do in order to make sure our infra is running smoothly? Here is when benefits of using vROps comes into picture. We have this intelligent monitoring tool which is not only capable of observing the behavior and collecting data regarding the objects, we can in fact use this collected data or metrics to monitor certain events and provide the capability to take necessary actions in case we need to notify the responsible person. And for this notifying, we create and use alerts definitions in vROps. And to keep track of such crucial events, we use something called symptom definition. Now, symptom definition is a key element when it comes to alerts in vROps. Basically, what an alert definition comprises of is first, one or more symptom definitions, and second, a set of recommendations and actions that we can take to resolve the problem. Symptoms, definitions, and actions combine to give alerts. So, yes, there are predefined alerts provided in vROps as part of our configured adapters. We can modify these alerts as per the need of our environment and also create new alerts for the same. Now, how would you define the symptom definitions? The name symptom definition in itself is pretty self explaining. A symptom is a feature which is regarded as indicating a condition of a disease or indicating the existence of something which is especially undesirable. And bingo, we need just that to work out for an alert or to even know that there is a need for alerting. Symptom definitions evaluate conditions in our environment that if the condition becomes true, the symptom is triggered and results in a generated alert. You can add symptom definitions based on metrics, properties, message events, false, and metric events. Um, you can add symptom definitions like metric based conditions such as usage greater than 90% or property based conditions such as if DRS is fully automatic and many others. And when you add this symptom definition to an alert definition, then it becomes part of a symptom set. Um, Symptoms are made up of single condition of an object, so multiple symptoms can be grouped into symptom sets. vRealize Operations comes out of the box with more than 600 symptom definitions. I recommend you to first spend some time getting yourself familiar with them as much as possible before creating a new one. Make sure an existing definition does not exist that matches your needs. By using the symptom definition search and filter options Realize Operations provides, otherwise, you may end up creating new definitions when there is an already existing one which can satisfy your environment. So, the symptoms in each symptom set are evaluated to be true or valid. And then there are two criteria to decide when a symptom is true and if alert will be triggered. The matching criteria can be of type any or all. In any, even if a single symptom evaluates to be true, then the whole symptom set will evaluate to true. And in case of all symptoms in the set must evaluate to be true in order for the symptom set to evaluate to true. Another concept that we need to pay attention to is the severity value of symptoms known as criticality. Now, criticality controls the color used to represent a symptom in user interface, which basically means is that symptoms can be divided into four categories and assigned a certain color so that just by looking at the color in the interface, we are able to recognize the severity of the symptom too, which is like info by gray, warning by yellow, immediate by orange, and critical by red. Alerts are made up of many symptoms and can be triggered in such a way, as I told you earlier, that either all the symptoms must be true or only a single symptom must be true to activate the alert. Now, the analytics component in vROps is the one who is checking the symptom conditions at the end of each polling cycle, which is every 5 minutes. The data which is collected from the monitored objects is sent to the analytics component, which then compares the data to the conditions in the symptoms definition and has already been said if condition is true then the symptom is triggered, which depending on the alert it is part of and the conditions applied on the symptom set, meaning whether it requires any or all to be true to trigger an alert, the alert is triggered. And the triggered alert can be seen at more than one place in vROps product UI, like on the alerts overview page, in the alerts tab of the object that triggered the alert, and also in objects summary tab. Now let's see what an wait cycle and cancel cycle is and how these are used. Wait cycle is, say analytics component has evaluated a condition to be true and we have set wait cycle to 1, which is also 1 by default, which means 5 minutes. So before the symptom is to be true triggered, the condition must be true after 5 minutes also. So if analytics checks the condition to be false now after 5 minutes, then the symptom is not triggered. This makes sure that we are being foolproof and certain when triggering a symptom. And now what a cancel cycle is, you see, if a symptom is active, it needs to be cancelled once the problem is fixed and the condition which initially triggered is evaluated to be false now. Once the condition becomes false, the analytics checks it for the assigned number of collection times and then declares the symptoms to be cancelled and cancels it. So, yeah, it is pretty useful and logically important. Now, let's understand this flow of alert being triggered. The incoming data is being sent to analytics component which evaluates the conditions and symptom definitions to be true. As you can see in the flow, if it evaluated to be true, the symptom is triggered and generated symptoms can be viewed in Active Symptoms tab in vROps UI. Now, Analytic component again checks for alert definitions based on triggered symptoms, and if the alert definition evaluates to be true based on the conditions that have been applied earlier, then the alert is triggered and can be seen in the active alerts in the vROps UI. I hope you are able to get this flow now. Now looking at the alerts tab and what all information it provides. as it gives us details about each triggered alert, such as criticality of alert, its descriptive name, which if it is a built-in alert, the name is built-in, and if you have created the alert, you give a descriptive name. Alert status, whether it's active or inactive, the object on which the alert is triggered, and what is the type of that object, assign owner of the alert. With all this, it also tells about the alerts in impact, like if it's on the health, risk, efficiency, the date and time at which the alert is triggered, and also the date and time at which alert is cancelled. The urgency of the alert is determined by its criticality and its impact, which in turn also determines what that which batch it will affect. Now, in the summary tab of the alert, you can find additional information such as object affected by the alert and its current state. Also, when you're looking for ways to resolve the alert, the summary tab is where you should start it. Another major part of an alert definition is recommendations. Recommendations are used to supply information on how you can fix alert that has been triggered. So, what all comes in the recommendations? There are plenty of built-in recommendations, but these can also be created manually based on your organization's policies and procedures. And what all the recommendations contain? Recommendation can be a single line or pages of text, or it could contain KB articles and contacts. And the single line pages are on how to fix the issue at hand. Also, when assigning recommendations to an alert, they are given priorities. This is because, as any administrator knows, there could be a number of issues that represent the same symptoms, so we can prioritize which recommendation would be more likely to be the fix, all based on environment's knowledge, which ends up decreasing the troubleshooting time. Next is actions, which is the feature that first came out in vROps version 6.0. An action provides a method for fixing the issue that you're trying to resolve. Only a single action can be assigned to a recommendation, and this is completely optional. As you can see in this flow, we have assigned a single action to a single recommendation and have left some of the recommendations as it is. So, if there is a possible action from whereof side that we can apply, then we can add an action with the recommendation. Now, where do these actions come from and what are the options available to us? The actions available to us in VROps either come built into the product or we can get more actions by installed management packs. Actions are fixed and cannot be created currently, and some out of the box simple actions are remove snapshot, add memory, add vCPU, remove vCPU, etc. Virtualize operations used to require the vCenter Python adapter solution to be configured. This is now part of the vCenter adapter only and can be enabled via the enable actions option from in the adapter configuration. Think about it. We have a known issue in the environment and we know the science. We are then in a condition to troubleshoot and fix it. It could be that we notice when the server's BIOS power settings have not been correctly configured, or we get specific CPU performance issues. So, for any issue, it is easy to reach to the solution. The following diagram shows an example scenario of how all this would fit together. We have conditions which, if evaluated to true, are causing the symptom to be true, and as the symptoms evaluate to true, the alert associated with them is evaluated to be true. As you can see in the flow, diagram, we have conditions such as average CPU demand is greater than 95% from 10 intervals and CPU usage is greater than 85% for 3 intervals. If the conditions are evaluated to be true, then the symptom associated with these are triggered, and as the symptoms are triggered, the alert associated with these are triggered and is evaluated to be true. And then we have recommendations, which are possible fixes for the alert. And if necessary, we can apply the actions, which are applied only if the certain conditions are met and we are in a condition to take the action. So, if we can work around other solutions, that will also work. With all these pieces coming together, they create one neat way for troubleshooting in an environment, especially when a good catalog have been created or modified to fit in with the environment. We can supply all the data needed to fix the issue as well as additional suggestions within a recommendation so that when an alarm is triggered, when the SME of the environment is not there, the lone junior server engineer can fix the issue as solution is right there in black and white. Of how these can be tied together and can be used. As mentioned earlier, actions are predefined and new actions cannot be created in vROps. Here in this example, we have three conditions. Memory contention is percent is greater than 10, CPU contention percent is greater than 15, and normally percent condition is greater than 95. And each condition has a symptom associated with it. There are two symptom sets. Symptom set 1 contains the symptom cluster memory contention at critical level, and symptom set 2 contains two symptoms which are cluster CPU contention at critical level and cluster compute resource anomaly is critically high. In this example, we can see that memory contention percent is greater than 10 is evaluating to be true, which is causing the symptom to be triggered. The second symptom, which is cluster CPU contention at critical level, is evaluating to be false because the condition is false, which is associated with it. The third symptom, which is cluster compute resource anomaly, is critically high, is evaluating to be true because the condition corresponding to it is evaluating to be true. Now, coming to the symptom set and the conditions in it, for symptom set 1 to be true, we only need any one of the condition to be true. And since it contains just one symptom and that symptom is evaluating to be true, symptom set 1 evaluates to be true. Now, coming to the second symptom set, we have two conditions out of which only one is evaluating to be true and the second one is false. But since we have a condition any, we only we only need one of the symptom to evaluate to true for the symptom set to evaluate to be true. So, coming to alerts condition, it needs all of the symptom set to evaluate to be true for the alert to be true or triggered. Uh, so, looking at this situation here, both of our symptom sets are true. So, all conditions is meet. We are meeting the all condition, which is causing the alert to be triggered. So, this is how symptoms and conditions and work in vROps. Now, these generated alerts can be viewed in alerts details and object detail in vROps. But you can also configure vROps Manager to send alerts to outside applications using one or more outbound alerts option. You can configure notifications option and outbound settings. Some of the examples are SNMP trap, standard email, REST notification, log file. You will learn about these in upcoming videos. Now we'll end this session. Thank you for making it till the end of the video. Bye bye.